Now we are going to talk about Young's double slit experiment. Okay. We yep, we talked about this before. So light sometimes behave like waves. Okay. Now Young, okay, actually is a scientist. Thomas Young is the person who proved that. Okay. Um, he's a scientist. He did a lot of scientific research. Okay. But the most famous of his um, theory will be the wave theory of light. He is the one that proved light behave like wave. Now, this week we're going to learn. Well, basically, we're going to learn how did he do that. Okay, so um, here is a picture of Thomas Young. Okay, he looks like that, and yeah. Okay, now let's go on to the. Let's talk about the experiment. Okay, so we learned that okay, wave. Yeah, before we sorry. Okay, we learned that okay, that wave has unique properties. It undergoes diffraction, okay, and it interference, okay, and yeah, with the superposition of waves. Okay, sorry, it yep. Okay, so Young came with an idea. Okay, he believes that okay, light is a wave, okay, and he wants to prove that light is a wave. Okay, so somehow in his experiment, he designed an experiment to show that light actually goes under diffraction, okay, and it interferes with each other. So once he done that, he can prove that light behave like waves. Okay, now, um, yep. So let me show you how he did it. Okay. So step one, what he did step one is he showed deflection of waves. So what's happened is he put a really uh, he put a slit. Okay. Uh, basically he has a wall, okay, and he put a slit in the middle. Then he shines light to it. Okay. Let's use yep this color. He shines high wavelengths of light, okay, to it. Now, what I discovered in the experiment was okay, once the light comes through the slit, okay, the experiment, well, it diffracts, it sprays out, okay, the light sprays out. Okay. Then what he did was he showed that again. He put another slit behind it, okay, but this time he put two slits behind it. So that's why we call it the double slit experiment. Okay. Now, as diffraction occurs, okay, as wave passes through those two slits, okay, and diffraction actually occurs between these two. So I have wave diffracts from one slit, okay, then I have wave okay, diffracts from the other slit, okay, like this. Now, then we have interference. Okay. So what happened next is Okay. He put it on a wall on the side. Okay, let's do it. Let's do it like this. Okay. He put a wall on there. Okay. And on the wall, okay, he discovered something. He discovered a pattern. He discovered a pattern like this. If I try to show you, actually, let me show you a good picture. He has something like this. Okay. Once the light went through it, okay, interference, we have those dark and light bands. Okay. So for instance, in the middle, he observes antinode, okay, where if you have a look at the picture, okay, where those show here. Well, in the middle, there's bright colors. Okay, we call this antinode. That means at this point, the wave meets constructively, and wave meet in phase, and constructive interference occur. Then we have brighter waves, means wave ending up. Okay? However, on the other part, we have dark bands. On those dark bands, we have nodal points. Okay? That's when that wave meets out of phase and destructive interference occur. Okay? Like what we talk about here. Okay? When the wave meets out of phase, they cancel out each other. That's why we can't see anything in that. We can't see any light, okay, in that dark regions. Okay? So, yep. Okay? So, yep, that's basically Young's double slit experiment. Okay? Um, now, okay, now let's have a look at this animation of Young's double slit experiment.
Young's double slit experiment. Interference in light waves from two sources was first demonstrated by Thomas Young in 1801. A schematic diagram of the experimental setup is shown here. Light was made to pass through a slit SO.
Okay, so when light passes through, diffraction occurs. So light diffracts, okay, and only wave diffracts. Okay. The idea is, if I throw a basketball through through a door, if I kick a football through a gate, okay, it will not diffract. It will not bend. Okay. But only the particle doesn't bend. However, light wave bends. So that's the step one of showing that light behave like waves.
The waves emerging from this slit was made to pass through two parallel slits S1 and S2. These two slits served as a pair of coherent light sources.
Okay, so once diffraction occurs, he made it happen again, but this time with two gaps. Okay, so we have an interference pattern.
Because waves emerging from them originate from the same wave front and therefore maintain a constant phase relationship. Thomas Young observed that the light from S1 and S2 produced on the viewing screen a visible pattern of bright and dark parallel bands called fringes. What causes bright and dark fringes? A bright fringe appears if the light emerging from S1 and S2 interfere constructively, and a dark fringe appears if the light from the two slits combine destructively at any location on the screen.
Okay, so yep, that's an animation of it. Okay. Now, the other here are the calculations between it. Okay, so now say, okay, let's make this diagram simpler. Okay, so I can show you the calculation part of it. Okay. So if I make this diagram simpler, okay, I will have two sleeves. Okay, S1 and S2. Okay. Then I will have, yep. Then I have a wall down this side, okay, and this wave just comes through. Okay, this wave comes through. I'm sorry for the bad drawings, okay, but just imagine they have beautiful wave patterns coming through. Okay. Now, yep, what we what we know is that, okay, so if I'm standing at any point, say if I'm standing here, okay, and what Thomas Young discovered is he discovered a way to figure out at this certain point, okay, uh, whether the two waves means constructively or destructively. Okay. The mathematical model he used would be, what he did was, okay, he measures, okay, the distance from any particular point to slit 1, okay, that's D1. Then he measures the distance of that point to slit 2, D2. Okay? So he figured out that, okay, if the difference, the change in D1 and D2, okay, in the distance D1 and D2, okay, if the difference is 0 or 1 wavelength, okay, or 2 wavelengths, or 3 wavelengths, or etc. Okay? Now we have bright colors. Okay? We have basically bright colors. Okay? We have bright bands. Okay? To be more scientific, okay, we can use all those fancy words we learned before. Okay? We have antinodal points. Okay? That's when the wave moves constructively. Okay? Constructive interference. Okay? Interference as a result of the waves meet in phase. Okay? This can be determined by the mathematical model. Okay? Now, remember this, it will be tested. Okay. Now, in contrast, if the change in the distance, well, basically the difference between D1 and D2 is half wavelengths, okay, or 3 half wavelengths, or sorry, 3 on 2 number of wavelengths, or 5 on 2 number of wavelengths, etc. Okay. We discovered that we have dark band. Right? And also in the exam, you need to be able to use all those fancy scientific words. Okay? So we have nodal points, we have destructive interference, and the reason we have destructive interference is that the wave moves out of phase. Okay, so that's what Thomas Young did. He did all this, Okay. And he discovered a mathematical model of it. And as a result, he proved that light behave like waves. Okay. Also, I attached another YouTube video for you to watch. I show you which one was that. Yeah, it's that's one. Now you can watch. You should watch this video by yourself, right? Because this is a replica of what exactly Thomas Young did in 1801, more than 200 years ago. He did this experiment, and this is a replica of how exactly he did it. Okay.